Hello, hi. Let's continue the chapter 3-3. So allow me to share the slide, chapter 3-3. Oscilloscopes and signal generator 3-3. This is the last chapter, subchapter in chapter 3. Oscillator in chapter 3-1, uh, it is about oscilloscope. 3-2, um, signal generator, function generator. So this is the oscillator. Requirement for oscillation, positive feedback amplifier, radio frequency oscillator, audio oscillator. Many electronic devices require a source of energy at a specific frequency, which may range from few hertz to several megahertz. This task is achieved by an electronic device called an oscillator, which is a circuit that generates an AC output signal without requiring any external applied input signal. So where is this oscillator used, or what are its application? So it is used in radio and television receivers. They are also used to generate high frequency wave in the tuning stages for the carrier wave. Oscillators are also widely used in radar, electronic computers, and other electronic devices. Sinusoidal oscillator. Sinusoidal oscillators are electronic devices that generate sine wave of desired frequency. Please note that oscillations are produced without any external signal source. The only input power to an oscillator is the DC power supply. So this is type oscillator, radio RF, and also audio. RF Hartley oscillator, audio Wien bridge and phase shift oscillator. So this is the two important terms. Oscillator used for an instrument that provide only a sinusoidal output signal. Generator applied to an instrument that provides several output waveforms, including sine wave, square wave, triangle wave. So please make sure that you can differentiate these two different terms. We have a function generator, then with this one is oscillator. What is the advantages of oscillator? An oscillator is non-rotating device. Consequently, there is little wear and tear due to the absence of moving parts. The operation of an oscillator is quite silent. An oscillator can produce wave 20 Hz until 100 MHz. The frequency of oscillation can be easily changed when desired. Good frequency stability and very efficient. Basically, an oscillator is an amplifier with positive feedback. So the signal regenerate and sustain itself. Regenerate and sustain. So this is the block diagram of uh, oscillator. Input signal, amplifier, A, output signal, then you have the feedback signal. So it will self regenerate. So gain for amplifier with positive feedback. So this is the formula for the gain. AF equals to A divided by 1 plus A beta equals to V naught divided by Vs. So then you can get the gain E, where AF gain with feedback, A open loop gain, B feedback factor. So positive feedback amplifier, a transistor amplifier with proper positive feedback can act as an oscillator. Please remember that a positive feedback amplifier is the one that produces a feedback voltage that is in phase with the original input signal. Positive feedback amplifier, a phase shift of 180 degrees is produced by the amplifier, and a further phase shift of 180 degrees is introduced by feedback network. Positive feedback amplifier oscillator, if we open the switch S, the figure, we will get the circuit as shown, open. It means that the input signal is removed. However, the feedback voltage is still applied to this input signal, okay, because you have the feedback voltage. So this is the positive feedback voltage. Oh, positive feedback amplifier. If a negative feedback circuit has a loop gain that satisfies two conditions to sustain oscillation, loop gain must be greater or equals to 1, net phase shift equals to 0, or phase amplifier factor A, B equals to 0. This is the Buck-Hausen criteria. Requirement for oscillation, it must be absolute beta gain greater than 1. The amplitude of the oscillation will continue to increase without limit. This resulting waveform, not exactly sinusoidal. The closer the value equals to 1, the more nearly sinusoidal is the waveform. Due to the circuit component, especially transistor change characteristic, age, temperature, voltage, and etc., it is clear that if the entire oscillation is left to itself, then you will find that in a very short time, A beta will become either less or larger than unity. Next is a Hartley oscillator, radio frequency oscillator. LC circuit is resonant when inductive reactance and capacitive reactance are equal. Okay, then this is the formula XL equals to the XC, then you will get 2 pi FL equals to 1 over 2 pi of C. Then you get the frequency oscillation with this formula where L equals to L1 plus L2 with the feedback factor beta negative L1 divided by L2, 180 phase shift across amplifier. Hartley oscillator, Buck-Hausen criteria, A beta greater than 1 to sustain oscillation. By solving the equation for inverting amplifier, you will get the A equals to negative RF divided by RI. RF divided by RI. So this is the example 1. So let's look at the example 1 and determine the frequency. Example 2, determine the minimum value of RF. Example 3, determine the value of L2. So you can try by yourself. If you have any problem, you can have a session, online session anytime during the class. So next is Wien bridge oscillator. The Wien bridge oscillator is essentially a feedback amplifier in which the Wien bridge serves as the phase shift network. The Wien bridge is an AC bridge that the balance of which is achieved at one particular frequency. So this is the circuit of the Wien bridge oscillator together with all the formula of the set. Wien bridge oscillator consists of Wien bridge and an operation amplifier represented by the triangular symbol. Okay, triangular symbol. The condition for balance for an AC bridge is Z1, Z4 equals to Z2 and Z3. Z1, Z4 must be equals to Z3 and Z2. Substituting the appropriate expression in equation 1, then you will get equation 2. This is the equation 2 for Wien bridge oscillator. Okay. So this is the real time, imaginary and imaginary. The equate real part, R3 divided by R4. Equate imaginary part, then you get the equation 4. So this is the Wien bridge oscillator. Okay. And from equation 5, you will get the frequency for the Wien bridge oscillator. 1 over 2 pi RC, which is F is frequency of oscillation of the circuit in Hertz, C is capacitance in farads, R is resistance in ohms. So this is the final equation. So this equation is derived from 1, 2, 3, 4, 5, 6, 7, 6 until 6. Then you will get the final formula for the frequency of oscillator. So you can try this example by your own. Wind bridge, determine the frequency of oscillation of the wind bridge oscillator if R equal to 6 kilo ohm and C equals to 0.03 microfarad. Next is a phase shift oscillator. So this is the circuit of phase shift oscillator. It contains of amplifier and as well as phase shift network. The phase shift network for the phase shift oscillator is an RC network made up of equal value capacitor and resistor connected in cascade as shown in previous figure. So you can get the feedback factor from the phase shift oscillator beta. If the phase shift of the feedback network satisfies the 180-degree phase shift requirement, the imaginary component must be equal to 0. Phase shift oscillator substituting for in equation 1, W in equation 1. And finally, you will get the gain V naught divided by Vi. The gain of the amplitude must be at least 29 if the current is to sustain the oscillation, means that the gain RF divided by Ri equals to negative 29. Okay, so you can apply the formula by trying this example. Determine the frequency of oscillation of a phase shift oscillator with a 3-section feedback network consisting of 30 ohm resistor and 100 micro ohm capacitor. So you can apply the formula, you get the F figure. So that is end of the chapter 3.23. Thank you very much. See you again.